Alright guys, welcome to 6.4 where we're going to look at, as a learning goal, you're learning how to graph by hand parabolas using a table of values. And we're going to continue with this idea of stating where your vertex is, your axis of symmetry, if it's a maximum or a minimum, if the parabola opens up or down, and finding your axis of symmetry with zeros or x-intercepts and y-intercept. Okay? So in the document that I have here, the first 1, 2, 3 pages I'm going to do together with you, and then the last 3 are your homework questions. Okay, it's because they have graphs, which is why it takes up so much room on a page, so don't think of it as, oh my goodness, I have 3 pages of homework. It's not like that. As you can see, the pages are taken up mostly by graphics. Okay, so we'll get started. So in this lesson, we're going to talk about parabolas and as well thinking about how to actually graph them using a table of values. So what basically you were doing before is you were taking Desmos and you were working through the process of just typing in an equation and then plotting those points onto a grid and seeing what happens there. And that's great. I'm glad that you did that on Desmos. I want to also teach you how to graph these. Okay, now there are multiple ways of graphing. I'm going to show you how to do it using a table of values for this lesson. Okay, so what we're going to do here, it says graph y equals x squared by first completing the following table of values. So first it's important to mention that y equals x squared is your parent graph. Okay, and we've used this word before, where your parent graph is like your base transformation graph. Okay, so what I have here on the left side, these are different x values, and they range from +3 to -3. Now, this equation that's in the middle here is where we're going to write out our work. Okay, so all I did was rearrange it, so instead of it being y equals x squared, it says x squared equals y. Okay, and the reason why I did that is so that we can kind of just keep track of all of our x's and working that out in terms of squaring our x's and then pairing that with our y. Okay, so here we go. If you are then taking all of these values and you're replacing it with the x position, how that will look will be like this. 3 squared, 2 squared, 1 squared, 0 squared, -1 squared, -2 squared, -3 squared. Okay, so remember, when something is squared, you're multiplying it by its base 2 times. So 3 to the power of 2, or 3 squared, is 3 times 3, which is 9. 2 to the power of 2 is 2 squared, which is 4. 1 to the power of 2 is 1 squared, which is 1, and that will be 0. This will be -1 squared is obviously +1. -2 squared is +4. -3 squared is +9. Okay? Now, these are all represented as our x value. Okay? So I'm actually going to go ahead and I'm going to write all these in a coordinate form. I'm sorry, just to clarify, your x values are the same values that we use as arbitrary points in the table. Okay, now we're going to pair that with our y. Our y is all the values that we squared. So this will be 9, 4, 1, 0, 1, 4, 9. Okay, so once again, you'll notice your x's are the same x's that are in this column. They're also the same x's that I squared. And those products, the answers, is what I worked out. And together we combine them to make a coordinate. So now I'm going to graph these. Okay, so this is my x, this is my y. So that can be 2, 4, 6, 8, 10. So every box is 1 unit. I'm just spacing it out so every 2 boxes represents 2 units, which is the same as every box is 1 unit, right? And remember, whenever you graph, you always have to label your axes, right? I need to know where you're following your axes grid, so depending on if you're going up by 1s, by 2s, and so forth. Okay, so we'll actually graph this. So positive 3, positive 9, so I go x to 3, y goes up to 9. I make a dot, okay? 2, 4, it's going to be our second point that I'm graphing. 1, 1, 0, 0, negative 1, positive 1, negative 2, positive 4, and negative 3, positive 9. You're then going to take those points and draw a U-shaped figure with arrows at the end. Now we're going to answer a couple questions about them. So state the coordinates of the vertex. So remember, your vertex is that important point where it changes directions, okay? So this is a vertex at 0, 0. Does the parabola open up or down? So remember, if it opens up, you're smiling. If it opens down, you're frowning. So in this case, this parabola is opening upwards. State the maximum or minimum value. So the minimum value is the y part in our vertex. So in this case, it will be y equals 0, and it is a minimum at y equals 0. State the equation for the axis of symmetry. Okay, so if I was to draw a dotted red line down the middle of the parabola, and remember, that's also the x part of your vertex. Okay, so in that case, that will be x equals 0. State the x-intercepts if they exist. So in this case, we do have one x-intercept, and your x-intercept is also your vertex. It just happened that they overlap. So 0, 0 is your x-intercept. What is the y-coordinate of each x-intercept? Always 0, because it will be x-intercept, comma, 0. Or x value, maybe that's a little bit more precise. X value, and then comma 0. Okay? State the y-intercept if it exists. So again, your y-axis is right here, and the graph crosses your y-axis also at 0. So state the y-intercept, 0, 0. What is the x-coordinate of the y-intercept? Always 0. So in this case, it'll always be 0 and then a number. Wherever that number is depends on where the graph lies on the y-axis. Okay? Okay. So that's our parent graph. Our parent graph will always have those points. That is your base graph. Okay? Now, I want you to think about a different type of graph. So I'm just going to move this down a bit. And in this graph, we have y equals x squared minus 2x. So you'll notice there's two spots where x has been represented. So for this one, we need to replace x in two places. Okay, so we got to sub it in here, sub it in there, with all the x values that I've suggested there for you. Okay, so let's try this out. X squared will be 4 squared minus 2 times x, and that will be the y part of the coordinate. So let's think about this. 4 squared is 16 minus 2 times 4, which is 8. 16 take away 8 is 8. 3 squared minus 2 times 3. So you'll see here your x values are represented in two spots each time. So 3 squared is 9, 2 times 3 is 6, 9 take away 6 is 3. Okay, it would be helpful if you guys had a calculator handy so that you can go through this easily, or you can always use your mental math skills. That's not always a bad idea. Careful with the negatives here. This reads as negative 1 squared, which is positive 1, and then negative 2 times negative 1 is positive 2. So we're actually doing 1 plus 2, which is 3. Same thing here. Negative 2 squared minus 2 times negative 2. That's positive 4. Negative 2 times negative 2 is plus 4, so that should be 8. Okay, so together we're going to create, once again, our coordinates. So all my x's are all the values that I have highlighted in green on the far left. So it'll be 4, 3, 2, 1, 0, negative 1, negative 2. I'm going to then pair that with all my y values. Excuse me. So I came up with these y values by substituting in my x for all those points. So 8, 3, 0, negative 1, 0, 3, 8. Okay, so use the color coding to track how we're getting these values, just so it's clear to you, okay? So I'm going to do the same thing here. I'm just going to start again because it was a little off. So every 2 boxes represent 2 units, meaning every 1 box represents 1 unit. Okay, there we go, we're all set. Alright, let's get graph in here. So I'm going to graph all of our new points. So positive 4 in the x, positive 8. Let's do that one more time. Okay, that's our first point. 3, 3, 2, 0, 1, negative 1, 0, 0, negative 1, positive 3, negative 2, positive 8. Okay, so you can see they always look like U-shaped figures. If for some reason you calculate some table value points and it doesn't look like a U, you probably had a miscalculation. Remember, we're trying to create U-shaped figures, not necessarily V-shaped, right? V is very straight and rigid, right? We want to have that curve because that's really what it is. It's a U-shaped curve. Okay, so we'll take a look again at our parabola that we drew. We do have a vertex at positive 1, negative 1, which is right here. We have two x-intercepts you can see, one at 2, 0, and one at 0, 0. So when we get down to that section, we'll make sure that we comment on that. Does the parabola open up or down? So definitely it opens up. State the max or min value. So because it opens up, it has a minimum, so a low point. And again, we got to use the y part of our vertex. So we say minimum at y equals negative 1. Your axis of symmetry, again, is the x part of your vertex. So where that dotted line would be if we were to draw it in. Ooh, that's not very good. Let's try that again. Perfect. Okay, so in this case, the axis of symmetry is at x equals positive 1. State the x-intercepts if they exist. So yes, we've counted two, one at 0, 0, one at 2, 0. And I'm just not going to answer these questions because we said that earlier. The y-coordinate is always 0. Okay, y-intercept. So in this case, your y-intercept, you'll notice here if I draw or just highlight your y-axis, your y-intercept does coincide with one of the zeros. So y-intercept is actually at 0, 0 as well. Okay, so you can see how we're starting to tie everything together. We're writing out our table of values, subbing in those values, graphing it on a Cartesian plane, and then applying the words that we learned last week. So vertex, opening up or down, max min, state the equation of the axis of symmetry, and then of course x and y intercepts. Okay. Alright, so I'm going to do one more question with you. And this one looks a little familiar, right? It kind of looks like our parent graph. However, that negative in front really throws it off a bit, right? We're like, well, you know, what do you think that possibly can mean? Because it kind of looks like the parent graph, but how can this negative in front of it change it? Well, I'm going to show you. Okay, so I'm going to take again all of my x values, and in this case, I'm just subbing it in to one spot. So this is really important because when you sub in 3, notice how that negative is always going to stand outside because it's part of the equation. Okay, so we're not doing negative 3 squared, we're doing negative, open bracket, 3 squared, and then applying that sign that's right in front of it. So I know 3 to the power of 2 is 9, then I got to include that negative. So that's actually going to be negative 9. I'm going to do the same thing here. BEDMAS. Brackets exponents. 4 squared is 16. Apply the negative. Positive 16 times, say, negative 1, because we know that there is that imaginary negative 1 that's on that outside, even though we don't see it. That's why that makes negative, why did I say 16? It should be 2. Sorry about that. So 2 squared is positive 4, and then slap a negative in front of it, that would be negative 4. We're going to do that for every one. And what you'll notice is all of these y values are going to come out negative. Because no matter what, except 0, 0 is a neutral number, no matter what, all of these values are actually negative because they say something about the graph and how it has transformed. So our new points, we have 3, negative 9, 2, negative 4, 1, negative 1, 0, 0, negative 1, negative 1, negative 2, negative 4, negative 3, negative 9, same thing, 6, 10. Ooh, there we go. Okay, so here we go. We're going to plot these values and see what happens. So positive 3, but negative 9. Okay, so we're actually going to go positive 3, negative 9 would be right here. Okay, that's that first point. Positive 2, negative 4. That's the second point. Positive 1, negative 1, 0, 0, negative 1, negative 1, negative 2, negative 4, negative 3, negative 9. Okay. So coordinates of the vertex, 0, 0. This one definitely opens down, so you can see it looks like that sad face, very different from the previous two. This one's going to have a maximum. And it's a maximum because my vertex opens, or my vertex has a turning point where it goes up and then comes back down, and the parabola itself opens down. Okay, so it's a maximum at 0. State the equation of the axis of symmetry, so remember that's the x part of the vertex, so it's x equals 0. There is an x-intercept, which is at 0, 0, and this is actually the same place where the y-intercept is, which is 0, 0. Okay? So what I'm going to get you to do, you're going to go through this homework question. You're going to do the exact same setup. Okay? I want you to consider all of these values, and you're subbing it in for x, and don't forget about that negative that's right at the front. Okay? Then you have these homework questions. So similar to what you were doing before, you're going to state the vertex, the parabola, does it open up or down, the maximum in value. I know it's very repetitive, but I want to make sure you know how to do it. Okay? You can just do these on line paper, on your own paper that you have. If you have a printer, you can print these 3 sheets. In terms of the graphing, okay, I realize not all of you may have graph paper. I posted some graph paper. You can print those if you have a printer at home on Edsby, or you can just make your own Cartesian plane for now using a ruler as best as you can. Just, you know, try to ensure that each box is representative of what a grid would look like, but do your best. Okay, that's all I ask. And yeah, that's pretty much all I got here for 6-5.